Hi friends, I am Rajesh. Welcome to my channel, Rajesh Maths Class. Today I am going to take a theorem, the density theorem. The density theorem. The density theorem. The statement is, if x and y are any real numbers with x is less than y, then there exists a rational number, small r such that x is less than r and r is less than y. That means r lies between x and y. Clear? If x and y are any real numbers with x is less than y, then there exists a rational number small r such that x is less than r, which is less than small y. That means r lies between x and y. Suppose this is our real line. If x, y are any two real numbers with x is less than y, then the statement tells us that there exists a rational number small r lies between x and y. Clear? This is the density theorem. Proof. Here we will prove this theorem in the case of positive real numbers. Clear? Similarly, we can prove this result for other cases. So we assume x is greater than 0. X is a positive real number. Also, given x is less than y. Clear? Okay. First, subtracting by x on both sides of this inequality. So this becomes 0 is less than y minus x. 0 is less than y minus x. That means y minus x is a positive real number. Clear? In this case, we will apply the second corollary of the Archimedean property. That means corollary 2 of the Archimedean property. Clear? The statement is, if x is a positive real number, that means if x is greater than 0, then there exists a natural number. Here capital means the set of natural numbers. Then there exists a natural number small n such that 0 is less than 1 by n and 1 by n is less than x. That means 1 by n lies between 0 and x. Clear? 1 by n lies between 0 and x. This is the second corollary of the Archimedean property. If x is greater than 0, then there exists a natural number small n such that 0 is less than 1 by n, which is less than x. That means 1 by n lies between x and 0 and x. Clear? So here we apply the second corollary of the Archimedean property for this positive real number y minus x. Clear? That means we can find a natural number small n such that here we can write such that 0 is less than 1 by n and 1 by n is less than y minus x. Clear? Once again, here y minus x is a positive real number. Then by the second corollary of the Archimedean property, we can find a natural number small n such that 0 is less than 1 by n, which is less than y minus x. Clear? Okay. So here we can write 0 is less than 1 by n, which is less than y minus x. Here n is a natural number. Clear? N is a natural number. Next, we consider this part of this inequality. this part of this inequality. That means 1 by n is less than 1 y minus 6. 1 by n is strictly less than y minus 6. Clear? Next, multiplying by n on both sides of this inequality. So we get 1 is less than n into y minus 6. 1 is less than n into y minus 6. Clear? Which implies 1 is less than. Next, we multiply each term in this bracket by small n. That means n into y equals ny minus n into x, nx. Clear? That means we get 1 is less than ny minus nx. Clear? Next, adding by nx on both sides of this inequality. So this becomes nx plus 1. Sorry, nx plus 1. Nx plus 1 is less than ny. Nx plus 1 is less than ny. Clear? So we can write here nx plus 1. Nx plus 1 is less than ny. Clear? Here n is a natural number. N is a natural number. Clear? Okay. Clear? Here n is a natural number. N is a natural number. Then we can write n is greater than 0. N is a natural number. Then we can write n is greater than 0. Also we have x is greater than 0. X is a positive real number. Clear? X is a positive real number. Then nx is a positive real number. Nx is greater than 0. Nx is a positive real number. Clear? In this case, we will apply the third corollary of the Archimedean property. Third corollary of the Archimedean property. That means corollary 3. Corollary 3 of the Archimedean property. Archimedean property. Archimedean property. Clear? Okay. The statement is, if x is a positive real number, that means if x is greater than 0, then there exists a natural number nx. There exists a natural number nx such that nx minus 1 is less than or is equal to x, and x is less than nx. Clear? Nx minus 1 is less than or is equal to x, which is less than nx. That means x lies between nx minus 1 and nx. This is the third corollary of the Archimedean property. Third corollary of the Archimedean property. Clear? Next, we apply the third corollary of the Archimedean property for the positive real number nx. For the positive real number nx. That means we can find a natural number, we denote it by small m. Small m belongs to n such that m minus 1 is less than or is equal to nx, and nx is strictly less than m. Clear? m minus 1 is less than or is equal to nx, and nx is strictly less than m. Clear? m minus 1 is less than or is equal to nx, which is strictly less than m. Clear? That means nx lies between m minus 1 and m. Clear? Here m is a natural number. M is a natural number. Clear? Okay. So we can write here m minus 1 is less than or is equal to nx, and nx is strictly less than m. Here m is a natural number. Clear? Okay. Next, first we consider this part of this inequality. That means m minus 1 is less than or is equal to nx. M minus 1 is less than or is equal to nx. Next, adding by 1 on both sides of this inequality. So this becomes m is less than or is equal to nx plus 1. Clear? First we consider this part of this inequality. That means m minus 1 is less than or is equal to nx. Next, adding by 1 on both sides of this inequality, this becomes m is less than or is equal to nx plus 1. But already we have nx plus 1 is less than ny. Clear? So comparing these two inequalities, we get m is less than or equal to nx plus 1, nx plus 1 is less than ny, nx plus 1 is less than ny. Clear? Okay. From this inequality we can write m is less than ny. M is less than ny. Clear? Okay. Next we consider this part of this inequality. This part of this inequality. That means nx is less than m. Nx is less than m. Clear? Nx is less than m. We have m is less than ny. M is less than ny. Again, comparing these two inequalities, we have nx is less than m and m is less than ny. Clear? Nx is less than m, which is less than ny. Clear? Okay. Here n is a natural number, then we can write n is greater than 0. N is greater than 0. Clear? Next, we divide each term in this inequality by n. Then this becomes x is less than m by n and m by n is less than y. X is less than m by n, which is less than y. Clear? Here m, n are natural numbers, then m by n is a rational number. M by n is a rational number. M by n is a rational number. Rational number. Clear? M by n is a rational number. We denote it by small r. We denote it by small r. Clear? Okay. So this becomes x is less than small r and small r is less than y. That means x is less than small r, which is less than y. That means small r lies between x and y. Here r is a rational number. R is a rational number. Clear? That means if x and y are any real numbers with x is less than y, then that x is a rational number small r such that x is less than r and r is less than y. Clear? X is less than r, which is less than y. That means r lies between x and y. Clear? Okay. So I hope you have enjoyed my class. Thank you.